Welcome back to the Deep Dive. Today, we are taking a run at one of the biggest sacred cows in 20th century science, special relativity. If you thought the basics of Einstein's theory, things like Lorentz contraction, time dilation, were totally settled science, you might need to buckle up for this one.
That's putting it mildly.
We're diving into sources that make a pretty provocative claim, which is that some of these core concepts aren't physical realities at all, but what the authors call a kind of mathematical patchwork.
Or an image trick. It's really an intellectual excavation. We're looking at a critique that argues 20th century physics, we're talking Lorentz and Einstein primarily, made a really catastrophic error right at the very beginning.
And what was that error?
They neglected the fundamental three-dimensional geometric reality of how light moves. And maybe most critically, they completely ignored the physical importance of the observer.
And that's really the core of what we're getting into today. Our sources argue we have to stop treating the observer as this abstract, dimensionless point in a coordinate system.
Right.
Instead, we have to ground them as a physical body, something that's actually absorbing light in a dynamic 3D electromagnetic field. So our mission is to see what happens when we force physics back into that real geometric environment.
And we'll do it using a few key examples from the sources, from the cosmic scale sun, Earth, North Star, all the way down to the terrestrial, like the classic moving train experiment.
Exactly. We're trying to find those aha moments that, according to these sources, prove that geometry dictates time and not the other way around.
So let's start with the history here, the context for this alleged failure. Classical physics, Newtonian mechanics, it was built on a solid foundation of Euclidean geometry, Cartesian coordinates. It worked.
But it had a hidden assumption, right? Instant information.
Exactly. The whole system works perfectly if you assume information transfer is instantaneous. But the moment you introduce Maxwell's electromagnetism and the finite speed of light c, everything changes.
Suddenly you have to care about where and when.
You do. You're immediately forced to define two things that classical math could just, safely ignore. The precise position in space where light is received and the exact time of that reception.
Okay.
And our sources argue that the generation of physicists tackling this problem, Einstein and Lorentz included, made a very specific conceptual mistake.
What kind of mistake?
Well, the sources use a Japanese term that they translate roughly as thought field narrowing.
Thought field narrowing.
Yeah. The idea is they focus so intensely on the mathematical formalisms, matrix algebra, the transformations, that they basically got tunnel vision. They narrowed their view away from the actual physical environment where all this was happening.
They forgot to look at where the equations were being applied.
They did. That's the claim.
But wait, I get that the speed of light is the game changer, but why would that make them ignore the physical body? Wasn't the observer implicitly part of the Cartesian system anyway?
That's the perfect question. And it's where this kind of philosophical rewind comes in. The crucial element they supposedly lost was what the sources call body existence.
Body existence.
And they connect it directly back to René Descartes. Descartes was really the first to consciously realize, I am here at one point on the Earth's surface. That's the fundamental difference, according to this critique, between math and physics.
The presence or absence of that measuring body.
Precisely. Mathematics can describe relationships in a purely abstract space, but physics, to be physics, needs that physical anchor. It needs a 0 point defined by your head and your feet.
So Maxwell gives them the beautiful math for the electromagnetic field.
Beautifully, yes. But when the next generation tried to just overlay those elegant equations onto abstract space without explicitly accounting for a physical body interacting with that field, well, that's where the analysis claims they failed. They abstracted away the measuring device itself.
And what's the consequence of doing that, of ignoring the body?
You're forced into distortions. If you ignore the physical reality of a body absorbing light in a dynamic 3D field, you have to resort to mathematical illusions to make the equations balance. And that's why special relativity, in this view, ended up needing concepts like Lorentz contraction.
The image trick.
The image trick and the patchwork that unnecessarily bends space and time just to preserve the elegance of the math.
Okay, so if the conventional model went wrong by ignoring the body in 3D geometry, let's put it back in. Our sources do this by setting up a really rigorous, fixed coordinate system.
Right. They create an observer they call Descartes Senior.
And we have to really visualize this to get it. So Descartes Senior, our observer, is placed right at the center of the sun. That's our origin, XCOY0000.
So that's our local camera eye.
Yeah.
But then you have to define the body's orientation in this huge space. How is he standing?
And they do that by using the body's scale to fix the z-axis. So you have to imagine the observer standing upright at the sun center. His head is at z+1, his shoes are at z1.
Okay, a body height of 2 units.
Exactly. And they align this 2-unit length with the cosmic north-south. So the North Star, Polaris, is set way, way up in the positive z direction. The Southern Cross is way down in the negative.
And just like that, you've fixed the observer's physical orientation relative to the entire observable universe. It's not arbitrary anymore.
Now we add movement. The Earth's orbit is simplified to a circle around the sun in that flat z-plane. Let's say it has a radius of 10 units.
And crucially, we add a known physical fact. If you're looking down from the North Star side, from the positive z direction, the Earth's revolution is counterclockwise.
Okay, so the stage is set. And this whole setup is designed to expose what the sources call the fallacy of a uniform now, or simultaneity. Let's just look at the distances involved, thinking of them as light travel time.
And let's look from the perspective of the North Star, our ultimate observer. So first, the distance from the North Star down to the sun. It's simple, it's a straight line. Let's call it 1,000 light seconds.
So the North Star sees the sun as it was 1,000 seconds ago. Easy enough.
Right, but now look at the Earth, which is orbiting 10 units away from the sun.
Ah, so the distance from the North Star to the Earth isn't a straight line down. It's the hypotenuse of a right triangle.
Exactly. The path is slightly, but mathematically significantly longer. If the distance to the sun is 1,000, the distance to the Earth is the square root of 1,000 squared plus 10 squared. It's a bit more than 1,000.
And that right there is the aha moment.
That's it.
Because the light travel distance is geometrically different, the image of the sun and the image of the Earth that arrive at the North Star at the exact same instant.
Must represent different moments in the past for those two objects.
They didn't leave at the same time.
Not at all. That slight geometric difference completely dismantles this idea of, a simultaneous plane sweeping across the universe. Our universe fundamentally isn't a unified now.
It's a geometric patchwork of past information.
Yes, where the time you observe is determined purely by the distance of the light source from your physical body.
So that cosmic geometry really establishes that observation is, by its very nature, an asynchronous act. Does this same principle hold true down here on Earth, say, with the classic thought experiment, the train?
It absolutely does, and this is where the critique gets, pretty fierce. So the traditional setup, you've got a light source in the dead center of a train car that's moving at speed v.
And special relativity claims that light reaches both the front and the rear ends of the car simultaneously.
But, and this is the key, only in the train's own inertial frame.
Right, for the person on the train. And this is the exact assumption the sources attack?
They attack it hard.
Yeah.
They suggest that this core SR premise, this internal simultaneity, is just an unverified belief.
Wow.
Yeah, and they use some really charged language here. They suggest this oversight came from a failure of critical thinking, not, intellectual malice or anything like that, more of a blind spot.
So they're saying the physicists prioritized the math over the detailed physical dynamics.
Precisely. They argue the oversight happened because the physicists ignored the physical reality of the light, competing with the train's own movement within the electromagnetic field.
Okay, so let's stop thinking about abstract frames for a second. If we just rigorously calculate what happens when light travels at speed c, and the train itself is moving through that medium...
The geometry demands a physical truth. The light must hit the rear end first.
Because the rear of the train is moving toward the point where the light was emitted.
It's closing the distance, so the light has less ground to cover. And conversely, the light will hit the front end later because the front of the train is moving away from the light source. The light has to play catch up.
So the classic SR premise, that the events are simultaneous for the passenger, is physically impossible if the train is actually moving relative to the medium the light is in.
It's just a physical fact of propagation. And that, they say, is the central flaw.
The domino that falls.
Right. If you force the math to require that impossible internal simultaneity, you then have to introduce distortions elsewhere, like length contraction, to explain why an outside observer sees something different.
But if you just accept that the rear end gets hit first, you don't need the subsequent mathematical tricks.
You don't. The problem solves itself with simple geometry. And this error, they argue, connects directly back to our cosmic setup.
How does a train track relate to the Sun-Earth orbit?
Well, the Earth's orbit is a curve, a circle. The train tracks are essentially a straight line, which is just the tangent line of a tiny segment of an orbit.
I see.
The principle is identical. When any observer looks at a moving object, a planet or a train, The distance from the observer to every single point on that moving object is changing constantly. Every single point.
And that was a key oversight. Lorentz and Einstein were calculating as if this distance was somehow fixed?
As if it were a 2D diagram on a blackboard, yes. By ignoring the fact that observation is the act of seeing points at varying distances, and therefore at varying times, they created a problem that allowed the mathematical illusion of length contraction to emerge as a necessary solution. They just failed to account for the observer's fixed position and the continuous dynamic change in distance.
Okay, so it seems pretty clear that rigorously defining the body, its fixed position, its orientation, its physical scale, and then combining that with the finite speed of light, it shows that geometry is what fundamentally dictates observed time.
And the conventional inertial system becomes, as the sources argue, kind of an abstract fiction. It's a way to bypass that necessary spatial reality.
So the goal here is pretty ambitious. It's to move the whole discussion out of what they call the punnel of narrow mathematical abstraction.
And back into detailed physical environment settings, where information delay and distance variation are, paramount. This isn't just about poking holes, it's about finding a physically sound path forward.
And for that path, they suggest looking back to an earlier pioneer, Henri Poincaré, and specifically his work on topology.
This is the proposed geometric solution. The physical environment, with all its constantly changing distances, is incredibly complex to calculate from one moment to the next. It's a nightmare.
Right.
But Poincaré's concept of topology might offer a way out. Topology is basically the study of properties that stay the same, even when you're continuously stretching or bending space.
So if we look at the Earth's curved orbit and the train's straight tangent line, those seem like two totally different paths. How does topology help?
Topology allows us to see the curve and the line as, in a sense, similar. It lets us standardize or harmonize those continuously changing distances,
Okay.
which then allows for simplified calculation in an abstract space. But, and this is the key, only after you've already accounted for the initial physical geometry. So you don't abandon math, you just make sure the physical setup is baked in before the abstraction starts.
So you're moving from a system based on these arbitrary time transformations to one based on confirmed spatial geometry.
That's the idea, exactly. Hashtag outro. So the core takeaway here is pretty powerful. The oversight of early relativity, according to this analysis, was ignoring the dynamic 3D geometry of light propagation. It was ignoring the continuous change in distance that's just inherent in any act of observation.
And that the act of measuring requires a physical body.
It requires a physical body.
Yeah.
And that body's specific position in space is what defines the resulting time delay in everything you see. The older physics just neglected to account for the actual physical observer who is absorbing the light.
The sources name this whole analysis the tunnel exit, which is pretty evocative. And they reference the sci-fi film Blade Runner in their conclusion. That's a striking image.
It is, because it gets right at the nature of reality itself. I mean, if this research holds, if our immediate conscious perception of the world around us, the scenery, the stars we see, is always this geometrically complex integration of light rays that left their sources at different times,
Times that were determined by distance.
determined purely by distance, then our subjective now is fundamentally a kind of memory-integrated illusion.
It's not a single objective moment in time. It's a tapestry that's woven together from a million different pasts, all assembled by our physical body at one specific point in space. And that really raises a profound final question for you to think about. If objective shared reality is just this geometrically assembled, time-delayed integration of past information, what layers of the past are you integrating right now to form your present moment?